I have a new dish. There's no car driving by. Let's see if I've been scammed. So this should be a 26 gigahertz satellite internet setup. So that includes the dish and the LNB and the internet router, basically the entire setup. Okay, first impressions are good so far. The geometry looks intact, doesn't seem to be bent. I mean, it is bent obviously into a parabolic shape, but doesn't seem to be bent out of shape. Seems uniform on both sides, so that's good. This is extremely heavy, but the main reason why I wanted to buy this, the dish, it was like an afterthought, I gotta be honest, is that I wanted to have this LNB. Oh, that's the heaviest LNB I've ever had. You can see the giant heatsink on it. What even is that sound? What makes that sound? Anyway, you can see the giant heatsink on it. We are going to be taking this apart, obviously. That's like the main reason why I wanted this. Because as far as I know, there is no video on YouTube actually taking one of these apart. This is probably the worst quality unboxing video on YouTube. Very simple modem technically, since you would be connecting this to your router if you actually had satellite internet. We have one connector for the LNB, one connector for Ethernet, and then a power and USB. Again, we're going to be taking a closer look at these, and I don't know what to do now. Let's see if we can assemble the dish. That's gonna be fun. Okay, I had to move the phone because it's actually starting to rain a little bit. So now you are hidden away under the big dish. So if it starts raining, the iPhone should be fine. As you can see, I've put it successfully on the tripod stand, and it's already quite heavy. It kind of wants to tip over with it. Oh look, there's a bolt on the ground. So this is definitely going to need some counterweights to be safe, but for now, just want to make sure it works. I'm gonna try to lock this. It doesn't really do anything. So that's this part done. Now comes the extremely annoying part, which is an extremely loud part, which will be removing all of these bolts and detaching this entire section of the mount. Let's get the wrench, because obviously this will not come out with this on top of it. Okay, it is a bit rusted here. I need to be careful not to break the paint, not to scrape the dish, because then it's just going to start rusting. What did I just say? What did I just literally say? Okay, take this off. So obviously this is gonna go in there like that. No, the other way around. It's gonna go in there like that. Okay. Okay, this is gonna work. This is gonna work. And now we can actually mount the dish itself. Let's clean it up a little bit as well. It looks like it's undamaged. It looks like it's not bent in any unwanted way. I suppose the fact that it's really heavy duty steel is what gives it additional durability. We are fine. There we go. It's really scraped up. I don't know if I did that. I'm gonna have to do something about that. The front is fine, but there's a big scratch on the back, and I'm not sure if I did that. I might have done it while removing this. I want to see if I can actually make the internet connection through the satellite. We are not actually connecting to a satellite. We are going to be aiming this at the KA-SAT, Viasat satellite. The LNB should be transmitting, as I said, at 28 gigahertz. Then the satellite takes that signal, relays it, transmits it down to a gateway ground station, and then the response takes the same path, except the other way around. Nice! Now we mount the actual feed arms. Two very beefy feed arms. Obviously, normally you have just one on the dish. I need to move this away so it doesn't interfere with the audio. Normally you have just one on the dish. This one has two in parallel. I'm using the wrench as a knife because I forgot where I put the knife. What I'm concerned about is the moment I put this in, the dish is just going to tip over. I guess there's one way to find out, right? So far I'm pleased with the build quality. This is the tipping point. Yeah. And that's without the LNB. Jesus Christ. You can already tell we're going to have to 3D print some adapter for this so I can mount my own feet if I want to use this dish with any other antenna. Although I kind of like this style of feed mount more than just a single arm, since this just gives it additional stability, which again is required at these high frequencies. So this is what actually holds the LNB in place. Okay, it says up here. I might have... Oh, it's fine, it's gonna be fine. I'm sure it works both ways. I do think I'm putting the bolts in there upside down. I don't think it matters, it's gonna look better this way. I'm going to show you, once I put the LNB on, we're gonna be able to see nicely where the focal point is. You can see the very long waveguide on the LNB. So if I put it on there, it's just going to tip over instantly. Yes, it is. But if I hold it in there, you can see the focal point is somewhere over here. So let's not do that right now, otherwise it's just gonna fall over instantly. We might be onto something here. Okay, so this actually uses a threaded rod to adjust the elevation. I'm not sure if you can see it. I will have to get that completely loose. Maybe I can just take this off. I don't know. This is incredibly annoying. Whoa! That's fine. Mostly out already. Okay, okay. This is progress. And it just slipped out. Okay. Can we take this out completely? Yes, we can. We now have free movement of... This is so heavy. We now have free movement of the antenna. However, it can't really go very high in elevation, it seems. Okay, but I'm very happy with this actually. This is better than I... Okay, at the beginning of the video it was worse than I thought it was gonna be. Now it's about exactly as I thought it was gonna be. So yeah, this is going this is going great. Let's mount the LNB on the dish just so we can get a photo for the thumbnail. Is this going to be it? Is this going to be the video? Just me assembling the dish? It's not very entertaining, is it? Okay, let's not mount the LNB on there and let's do it later when the weather is cleared up. And we're gonna see if we can actually achieve an internet connection with this dish. Plus it should be possible. We should be able to connect to the ground station of this internet company. We're just not going to have access to the internet. To the World Wide Web, I should say. Okay, I have the LNB mounted. The weather is nicer now, so we should be fine. And we should be able to actually see if we can connect to the internet, let's say. It is insanely heavy. I have never had anything this heavy on this tripod before. I'm not sure if you can see it. Actually, let me move the view. I want you to see it. Yeah, the entire tripod is just flexing. This is not good. I did watch one video, one very old, outdated video on how the installation of the Viasat internet, of the two-way internet actually works. But I don't really remember anything. And I figured it would be more fun if we actually try to figure it out as we go. So I have the router here. I have my laptop with me as well. This thing has a massive, comically large power supply. This is a 30 volt, 3 amp or 2.7 amp power supply. And I did measure it. It is passing the 30 volts directly to the LNB. And on the back of the LNB, it actually says it runs between 24 and 57 volts. So I think such a high voltage is needed for the power amplifier in the transmit stage. Here we have the router itself, as you've probably seen already. I'm not sure how much of the previous video segment I'm going to keep. Here we have the router. So it has an F connector, it's just going to connect directly to the LNB. Short Ethernet cable, so everything that we need is in the box. That's great. And we also need AC power. I have an extension cord here. I'm probably going to die because there's like a centimeter of water everywhere. Okay, there we go. There's our AC power. What even is that machine? It's a sprayer. It's an agricultural sprayer. So you're going to have nice ambient sounds of chickens screaming in the background. Giant diesel engine running idle. Really, this is the content everyone is tuning in for. We're just going to hand aim it, hand track it. We don't need any aid. It's gonna be fine. I've blindly found so many geostationary satellites already. I do not need a pointing calculator. I'm saying that right now, and I bet in a couple of minutes we're gonna have real issues trying to find a satellite. I am plugging in the router. The router is plugged in. We are getting blue lights. Okay, 3, 2, 1, recording. We do have actually green check marks on the LNB. Okay. TX power, TXRF power. The copyright is 2010. 2010. So as I said, I watched a video on this where it basically started beeping and they used the sounds to aim at the satellite. I don't know how to activate that mode. Also, I forgot that my touchpad on the ThinkPad is malfunctioning. You can see I'm not holding anything and it's now selecting. So I have to cut the recording, close the ThinkPad, wait for it to go to sleep, open the ThinkPad, that power cycles the touchpad, start the recording, 3, 2, 1, now, and we are back with a working touchpad. How are we going to aim at the satellite? Okay, come check this out. This is the setup we are working with right now. Obviously we have the LNB here, and we have the main cable and we have the main cable and an end on the cable. That's important. It goes into a splitter, so this is where the input from the LNB goes, and then another short piece of coax takes it to the router, so that's the standard connection. But then we have another coax going from the splitter, and these two unused ports, I just put 50 ohm or 75 ohm terminators there to hopefully prevent any reflected waves, whatever. Then we have the coax goes into a bias T, which in this case is only being used as a DC block because this thing is outputting 30 volts DC, and this splitter, as you can see, it says power pass, so all of these ports are getting 30 volts on them. Obviously that would kill my SDR, so I'm using the capacitor in this as a DC block. Then we have a couple attenuators there just to be safe because I'm gonna reduce them as we go, but I figured it's safer to start with the highest attenuation, so that's 20 dB, 10 dB, 6 dB, I don't know, 3 to 1 probably, because I have no idea what the power level of the LNB output is. And we have the NESDR Smart T XTR. That's because this is one SDR that I don't want to say that I wouldn't mind if it got damaged. I would mind because this is my only XTR, but mainly this can go up to 2 GHz. So that will allow us to probe the widest range of the LNB output. Obviously the HEC-RF would be ideal for this, since that can go anywhere where the LNB would output, but I really don't want to risk using the HEC-RF with this. You know, we're gonna see. If this doesn't work, maybe we will switch to HEC-RF. But first, we actually have to aim it at the satellite. So I figured I would use the SDR and look at the waterfall to aim the dish, but then I realized I have no idea what frequency I would have to tune with the SDR, because I have no idea what local oscillator value this LNB uses on the downlink. I could not find it online. Admittedly, I didn't really look for very long, but I did look at the video. Okay, we need to power it up because I disconnected it. I'm not gonna use OBS before because you saw my issues with the recording and the touchpad. I constantly have to stop the recording. I'm really sorry, but yeah, we are connected to the thing. I can refresh the page. We are connected to the modem, to the router. Actually, it's a modem. I'm gonna call it a modem. So there is no button, there is no link to actually enter the setup process. What you have to do, and this is actually very intuitive. I have no idea how I did not figure it out. You have to go to the URL bar and type in install and press enter, and there you go. This is the actual cool part about how this technology works. So I kind of want to talk about it. You can see, select your beam color. So the satellite that we are aiming at, the Viasat KA-SAT 9A, there we have it. It has like 100 spot beams all over Europe and the neighboring areas. Obviously, these are tiny spot beams at the Ka band at 28 gigahertz, I think, probably, maybe. No, 20 gigahertz will be the downlink, right? So every small area of Europe and the areas around it has its tiny localized spot beams. So I think there's 2 spot beams that cover the Czech Republic and neighboring countries. Basically, so you don't get interference between the 2 spot beams, right? Because if you have one LNB or one user receiver like this in one spot beam, you don't want it to see the traffic coming from the neighboring spot beam, not because of security reasons or anything, but simply because it would be wasting bandwidth, right? They would be interfering with each other because the spot beams are not perfectly sharp. The beam pattern is not perfect. There is some overlap, some overspill. They have 2 frequencies on the downlink and 2 polarizations on the downlink. And depending on the combination of frequency and polarization, you have different colors. So you don't have 2 neighboring colors. So as long as the 2 neighboring cells, the 2 neighboring spot beams, don't have the same polarization and band configuration, so you have a low band, high band, as long as they are not the same, they will not interfere with each other. But that means you need to know what your quote-unquote color is. So this is basically just a way to make this more user-friendly, because obviously your average user, they don't care about what polarization and high band, low band means. So you just have 4 colors for the 4 combinations of bands and polarizations. And there you can see all of the spot beams around Europe. And I guess, wait, these colors don't match, or do they? No, they don't. Oh no. These look like they match. Obviously, is that it? So I would be in a purple one. Yeah, I am in a purple spot beam. So you can see. So here the colors don't match, but it's the same idea. Yellow and green are RHCP, blue and orange are LHCP. And you can see this is the LHCP, this is the RHCP, but every alternating spot beam has a different band. So I don't think it says here, it doesn't, but let's say yellow would be low band, green would be high band. So even though they are the same polarization, because each uses slightly different bands, slightly different frequency offset, they will not interfere with each other. So if you are at the border of the 2, you can still only select one as your color. Anyway, as I was saying, I think I'm in a purple spot beam. Wait, this is it, right? So that's 2010, so I guess, yeah, so I guess this would be around the time when KA-SAT came up. So I guess this was always meant to work with KA-SAT, whatever. I thought there was some other satellite before KA-SAT, I guess not. So as I was saying, I am probably in a purple spot beam. I have no idea, let's see. Go. Jesus Christ, the dish just made a sound, probably from thermal. Oh! Do you hear that? Wait. The LNB itself is beeping. I thought it would be the user interface from the laptop. In theory, we should just unlock the rotation of the dish, and using the sound of the LNB, we should be able to aim the antennas. Although we are aimed at like 60 degrees elevation, we probably have to take down the elevation a little bit. Yeah, I did not think that through. I forgot how heavy it is. Okay, so this is the azimuth. It's squishing my hand. Oh God! Oh Jesus Christ! I need to lock the azimuth. Oh, fuck. Oh. Bruh. Did we get it? 5 decibels. 4.7, 4.1 is going down. That's our thing. That's our actual connection. We are actually receiving packets from the satellite. We should at least trace to the satellite ground station, right? Or does it just cut off completely the physical layer? I guess it does. We only get to the modem itself. But now we know we are aimed at the satellite, so we can actually connect the SDR, because now we should be able to see the traffic on the IF. So I think the transmit is in the L band, but we should definitely see something on the downlink. Okay, is this it? Oh, that's it. There's the satellite transponder. It's just so wide that it will not fit. That's it. That's the internet data. It's mostly filler, it seems. I kinda want to get the heck RF on this. Or we get the AirSpy Mini and use Spectrum Spy to see the full bandwidth. I'm sorry, this is probably not visually appealing at all, but if this is something you're interested in, it's kinda cool to look at. Right now we're just seeing a bunch of noise, bunch of random spikes in the spectrum. There should be 2 transponders, so this is one, and there should be another one. And they hire. Okay, there is. Okay, nice. So we are actually seeing. So the transponders may be only 30 megahertz wide, and I was looking at both of them combined. Okay, never mind. Is this a third transponder? Yeah, we really need to run Spectrum Spy on this. But it was saying in the modem statistics that we are transmitting packets, are we? Yeah, we are. So there must be, and we might have to hook up the heck RF to actually fully probe this, but I still want to do the AirSpy Spectrum Spy analyzer. Okay, so we have an issue. I'm not sure if you just saw that. I'm trying to connect the AirSpy Mini, and it won't. It just will not. I'm gonna try rebooting the computer. You can enjoy the view of the grass for a while. I don't know why SDRs are so annoying. I mean, everything involving USB is just incredibly annoying. USB and Bluetooth are the 2 worst inventions that mankind has ever conceived. Open Spectrum Spy. Okay, so unfortunately I was not able to get the AirSpy Mini to work, so now we are running with the heck RF. I removed one of the 20 dB attenuator, and as you can see, this is the downlink. I've tuned to the edge of one of the downlinks, so you can actually see the signal better, and you can very nicely see the activity. So right now it's transmitting some filler frames, and it should shortly transition into some data. Come on. Now it's doing short bursts of data, and now there was some more data, and now it's transmitting a lot, and it's slowly going back into filler. But now that we have the RF, we can actually keep going up and see if we can spot any activity on the uplink, because the modem should be transmitting some. Wait, hold on, what was that? No, that's some interference. Okay, we should be able to go. Hello, you can see me in the horrible screen reflection again. I'm really sorry about this. Like, this channel is actively going downhill in terms of quality. It's fine, who cares? There's some flies flying around. I'm not seeing any uplink activity, so I'm really not sure on what frequency the modem actually transmits into the LNB or into the up converter part of the LNB. It has to be doing so because it is saying in the web UI that we are transmitting packets. The transmitted bytes are still going up. Oh no, am I zoomed in all this time? I'm so sorry. The transmitted bytes are still going up. Transmitted packets are as well. It's like 4 packets per second. So we should be seeing some like really frequent activity. Could it be below the downlink? Could the uplink be below the downlink? Jesus Christ. Yeah, you can tell that we have removed the attenuators. Look at it, that's beautiful. Okay, okay, I need to stop. We are looking for the uplink. So this is the very strong downlink. That's great, that's awesome. But we are looking for the uplink. I guess it could be below the downlink. So far I've only been looking above it. For example, here there will be basically no bandwidth. Let's see, I'm gonna put my hand in front of the LNB. Okay, and it disappears, so that's not the uplink. That is actually the downlink, and this means we are actually receiving some narrowband signal from KA-SAT. That's nice. I wonder if we can see some other signals. Hold on, look at this, look at this. Although this looks like more downlinks. I'm gonna do the hand test again, although I'm pretty certain this is a downlink signal. Yes, it is. So unfortunately, the mystery of where the uplink is remains unsolved. So if you have some idea, let me know in the comments. I wanted to do the teardown of everything in this video, but I feel like this is already going to be extremely long. So what I'm going to do now is I'm going to download Spectrum, or you know what I'm actually going to do? I'm gonna use the 20 MHz bandwidth of the HEC-RF and manually scan across the downlink band and stitch together one big picture, so you can see all of the 4 downlinks put next to each other with frequency labels and a nice waterfall from SDR Sharp, as if it was in Spectrum Spy. I'm gonna put that in the video, and for now I bid you farewell, and I hope to see you again once we are actually doing the teardown of everything, and I do mean everything. We're gonna be taking apart the LNB, the modem, and even the power supply, because I want to see why it's so huge. But all of that is going to happen in a future video. I just realized I was putting my hand in front of the LNB while it's transmitting. I should not have been doing that.